So it's time now to look at mean, median, mode and range in detail. Now the mean is a real good one for this because actually it's probably the most straightforward of the group. Because you're adding up the numbers, so you have to have numerical data, and you're dividing by the number of values. So, things that we need to be clear on. If I have these values, zeros do count. So the mean here is add them all up, divided by the number of values. These values are also possible. So I add them all up, I divide by the number of values. So your mean could be 0, or it could be something like 2 in this case, and the zeros do count as a value, even though they are 0. You can also do the mean with fractions and decimals. Now, the thing about the mean that makes it really powerful is when you have a large set of data, it can be quite an accurate description of something. So let's look at a situation where the mean develops. So here are some test scores from a class out of 20. Now I can work out the mean after just 2 scores, which will be 36 divided by 2, which is 18. The next test score is 24. So the mean of the 3 scores now is 60 divided by 3, which is 20. Notice how the mean is changing. The next test score is 40. So now it's 100 divided by 4, which is 25. The next test score is 42, followed by a test score of 38. So now it's 180 out of 6, so the mean is 30. And you can see the mean has been jumping quite a lot as the results change. But watch what happens now. Another 17 and a 23. So we're up to 220 out of 6. Out of 8, sorry. Well, let's have a look what that's going to be. $27.5. The mean made some really big gains in the middle here, going up 5 and then 5 again. But then it's only dropping by a small amount. This is because when lots of results are already collected, your mean isn't going to change much. So another 17 and a 23, another 40 takes me to 260. So the mean drops to 26. So the big jumps of 5, 5 are now starting to shrink to much smaller jumps. So when you have a large data set, lots of data, your mean can become quite reliable. But watch out if you just have a couple of pieces, because these 2 pieces actually were nowhere near the mean for this data. Now let's move on and have a quick look at the mode. Now the mode is the most commonly occurring value. So it's really easy to spot sometimes. Here it's 2. But because it's a value, it also works in this situation. So these are 5 cars that went past my house in the last 10 minutes. What's the modal car? The most common car. Well, it's red. What's the mean car? Well spotted. You can't have a mean for colours. You can't add colours together. Of course you can in art, but in maths you cannot add them together. So with mode, it works for numerical data and non-numerical data. So, let's track on to the median now. Oh no, tell a lie. Here's another set of data I need to teach you about. What's the mode here? Well, this data is what we call bimodal. That means it's got two different values which are its mode. How can this happen? Well, it's quite easy really, and there's a very common case that happens in society. Now this is a bad drawing, but I think you'll work out what I'm trying to draw. Nope, probably not. Let me put some laces on it. Shoes. We have a bimodal situation with shoes in the UK. We have two groups of people with different sizes of feet. One group has a mode of something like 8 and the other group has a mode of something like 4. So shoes overall are bimodal. And you've probably guessed that it's a female to male split there. Now, you can also have trimodal, but at the point when you get more than two modes, you tend to say there is no mode. Okay? So because having lots and lots of modes actually doesn't tell us anything. One or two, if there's a clear particular aspect that makes you split it, is fair enough. But you don't want to have 6 different modes for males and females, then split into children, teenagers and adults. It's not necessary, and actually it becomes misleading. So, let's move on now to median. Here's a lovely data set, all in order. What's the median value? Good, it's 8. Can we have a median value if we have colours? Nope, you're thinking, because they're not numbers. What happens here? What is the median for this data set? So it's not the n numbers, and it's between these two. So it's 8.5. What about these numbers? So it's between these two. And what number is halfway between those? So sometimes you'll want to write it out to see the list. (14) is the median. The other way of doing it is, what's the gap between here and here? Well, the gap is 4. So if we want to do half of that gap each side, that's 2 each side. So 12 plus 2 takes me to 14. So here we've looked at some of the key things you need to know about your averages. By now you should have practiced finding the mean, median and mode. And in the next section we're going to look at what you do when given a set of numbers. Sorry, I tell a lie. Given a set of rules like the mode is 5 and the mean is 6. And you're going to have a question like, what are the 4 numbers? So we're going to use these rules backwards.